Hi, this is Rong. Our project is PubMed database analysis and trend visualization. Next, my teammate Liangyu will talk about the introduction part.
Here's the agenda for today's presentation. I'm going to give you guys a brief project overview, introduction of PubMed, explain the motivation of our project and what tools and dataset we use. After that, I'll show you guys the system architecture. Later, Rong will talk about more details in method, analysis in performance and results. Also, he'll make a discussion on the future work and make a conclusion. Satisfying clinician information needs often requires access to up-to-date literatures. While online literature is a potential but underutilized solution because of some barriers to access, programs have developed to address this problem by using computer-based patient information to formulate search strategies and carry out some retrievals, such as concepts from free text can map to a standard vocabulary. However, right now, we do not have a user-friendly interface that contains multiple functions for clinical research. Our project designed a website that user could automatically map ICD-10 disease terms to match for the literature searching in PubMed. Then, with those literature information, user could read more publications from the co-author based on the author networks. Furthermore, user could also have a brief idea of the current trend in disease search from our project result. Let me make a short introduction on PubMed. What is PubMed? PubMed is a free web-based interface for searching Medline. It is created by the National Library of Medicine and contains the Medline database. It covers journal articles in medicine, nursing, and so on. PubMed has information about over 24 million journal articles, and NLM indexers add words called match medical subject heading to the information about each article. Searching with match words can help us find more relevant articles. The first motivation is that we want to identify free text information such as ICD codes in an electronic patient record and translate it into match terms. With medical subject headings, we can automate research on PubMed database for exploring potential remedies. Later, we want to find the most important author for a certain disease via network mining approaches. With the cancer trend analysis, we can make a good prediction for the research funding investment. Also, the anticipation of changes in the ontology could predicting new knowledge. Here is the tools we use in our project: PubMed, PubMed API, UML's API, PySpark, Chart.js, Vis.js, AnyChart, JavaScript, Django, LDA model from PySpark. For the dataset, we download publications related to 433 PubMed disease match terms. We only use the abstract information, author information, PubMed IDs, keywords, journal information, publication dates, and DOI of these publications. For the author network, we gain the author information from the literatures on cancers from 2009 to 2018. And also we use the keywords in these literatures for the cancer trend analysis. Here is the system architecture of our project. We download the data from PubMed and then apply relative information on different tasks. For the task ICD mapping, we first use UMLS to map ICD terms to match terms. If there's no mapping, we just return no results. If there's a mapping, we want to check whether the data related to the ICD terms is already downloaded locally. If it's not downloaded locally, we can redirect the user to the PubMed website. While if we already have the data about the ICD terms, we can present the related articles, PubMed IDs to the users. For the author network task, the relation network was constructed based on the 1-degree relationship among authors, which was obtained through published papers. The current author is in the center of the network, and the strength of the relationship was indicated by the width of the ages. For the cancer literature analysis task, we first count the number of the articles published from 2009 to 2018, and then we calculate the weight of each keyword in each year. After that, we calculate the weight of each journal in each year as well. Then we used the LDA models to analyze the topic in cancer literatures among these 10 years. After all finished the 3 tags, we combined them together to create a website.
Here are the methods that we applied in our project. For the dataset preparation, we use the PubMed and PubMed API to send the request and download the necessary data. And we also use the UMS API to map the ICD term to mesh terms. PySpark was applied for the authors network and the cancer literature analysis. Meanwhile, the LDA model in PySpark machine learning library was applied to analyze the topics in PubMed literatures. And finally, we used the Chart.js, VS.js, and Chart, JavaScript, and Django to create a website and provide visualization for the data. Here is what our website looks like. It mainly includes 3 parts: ICD search, authors network, and cancer analysis. Here is the user's interface of ICD search. You can just type in any ICD term that you are interested in and hit the submit. The result will be shown below. And more than that, you can click the PubMed link for more details of the article. Here is the user's interface for authors network. You can just type in any author's name and then hit the submit. The network will be constructed automatically, and the results just like that. So for the cancer trend analysis, this graph presented the number of articles published from 2009 to the 2018. So among the 10 years, the general trend of number of cancer articles published increased steadily, and there was a significant increase, which was about 16% in the period of 2013 and 2014. Unfortunately, the increase is not unlimited, because the increasing rate slows down over the 10 years. Cancer research seems to face the bottleneck recently. So here is a graph for the cancer literature. The y-axis here presents the index, which is the frequency of the keywords divided by the total number of articles published in each year. The x-axis represents the year. The top 2 keywords are cancer and breast cancer. From the graph, we can see that obviously breast cancer is much more significant than the other key terms, than the other keywords. We selected several keywords with unique characteristics and classified them based on their trend. For example, prostate cancer, chemotherapy, melanoma, immunohistochemistry present the decreasing trend. The prognosis, apoptosis, lung cancer immunotherapy present an increasing trend. And we think that the keywords with increasing trend will become the potential hotspot in the near future. For the immunotherapy, the keyword seems to become popular starting from 2015. And we searched some information of the keyword. We found that the FDA approved the immunotherapies in 2015. And immunotherapy was considered as the 2016 Clinical Cancer Advance of the Year. And in 2018, the Nobel Prize was awarded to the cancer immunotherapy researchers. I think that is the reason behind the trend of these keywords. Here are the keywords that have the periodic characteristics, the information and the oncology. They seem to disappear in the year of 2016 and 2015, and they started boost again just like 1 or 2 years later. So this unique phenomenon is very interesting. We did the similar things to the journals which publish the cancer literatures. And we found the top 3 ones were OncoTarget, Scientific Reports, and PLOS ONE. Again, we select several journals and classify them into two classes based on their trend. Onco Letters, Medicine, BMC, and those journals presented increasing trend, which means they prefer to accept papers about cancer research. And for Oncotarget, Scientific Reports, and PLOS ONE, they presented decreasing trend, started from 2016 as the earliest, and it seems like they increased the criteria of accepting the cancer literatures. So if you want to publish your paper about cancer research, you can just choose Oncology Letter, Medicine, BMC Cancer in order to increase the probability of acceptance. After feeding the PubMed literatures to the LDA models, it generated 10 topics, and here are the word clouds for the 10 topics. And for each topic, it is described by 10 words, so we manually assign the name based on the description to each topic. And there were prostate cancer, chemotherapy, genetic profiling, and melanoma, and several. You can just select the topic that you are interested in, then the words related to this topic will be highlighted as a black, just like the example here. If you select the brain radiology, the words like radiation, dose, images, brain will be highlighted as a black, and the size of the words represent the probability of the word present in that topic. For the future work, we could do some data enrichment, which means we could expand the dimension of the data by adding more information, such as the number of citations of the articles, the whole content of the article instead of the abstract alone. And for the authors network, we could expand the first degree net relationship to the second degree, and that could include more potential relationship for the author. In order to predict the trend more accurately, we could apply more machine learning methods such as linear regression or CNN. And third, we could improve the quality or appearance of our user's interface to have a better visualization. So for the conclusion part, our project mainly solved the three problems. It assists the clinicians or researchers to have a quick access to the literature in PubMed, just based on the ICD-10 terms. And second, it can allow the users to have general ideas about the network of the authors, and it can reflect the author's status or importance in that field. Third, the analysis of the cancer literature presented the trend of the cancer research and also provided some evidence of the future hotspots. Students in life science may be inspired by the trend over the past 10 years, and then they will plan their future research in a more efficient way. And last, PySpark and front-end tools like ChartJS could perfectly deal with big data processing and visualization. So here is our website. You can use the ICD search. You can check the ICD search, authors network, and the cancer analysis. Okay, for the ICD search, you can just type in any ICD terms that you are interested in. For example, here the brain injury traumatic, and hit the submit. The result will be shown here. The articles, and you can click the link to have details about the article. And for the authors network, again, you can just type in any author's name that you are interested in. For example, here, the Richard E. Champlain. The network will be constructed, and again, the numbers shown on the edge represent the number of articles that published by the two authors together, and the contact information and the number of friends will be shown when mouse hovers over the nose. Here is the graph for the cancer analysis, and you can check the exact number of published articles for each year. And here are the keywords for the cancer literature, and you can exclude some keywords if you want. The frequency of each keywords in each year will be shown here. And again, here are the journals for cancer literature, which is similar to the keywords. And this is the topics in the field of cancer among the 10 years. So for the brain radiology topic, the words like radiation, brain, the image, dose belongs to this class, belong to this topic, and they are highlighted as black, and the size of the words represent the property of the words present in this topic.